In this presentation, I'll be explaining different chopper control techniques. Now let us see the different control techniques of the chopper. One method is called the time ratio control or TRC, time ratio control method. Second one is called as current limit control method, CLC. For TRC and CLC are the two methods to control the chopper. For here, this is a step down chopper what already discussed, and in that one you have to control the duty ratio of the switch so that variable output voltage can be changed. Now this can be, the variation of the duty ratio can be done by any two methods like TRC as well as CLC. In time ratio control techniques, the duty ratio, because duty ratio is given by on period divided by the total time period T. That is, duty ratio is given by T on divided by the total time period. Is varied, duty ratio is varied. Now this duty ratio variation can be done in time ratio control by one method is to change the T on or T off, both can be done, keeping the T constant. That is called, frequency is to be constant frequency operation in which you will be varying the on period and you are changing the duty ratio. That's a one method. Second method is that we'll be keeping the T on constant or T off constant and we'll be varying the T time period or varying the frequency. Therefore, the TRC can be implemented by, or that control technique can be implemented by two methods. That is, one we call it as constant frequency operation. In constant frequency operation, the time period T is kept constant, or automatically F equal to 1 by T, which is kept constant. T is kept constant, varying either T on or T off, both can be. Or if T on varies, T off also will be automatically changing. Therefore, in constant frequency operation, time period T is kept constant and either you will be varying on period or off period. Second method is T is made to vary, or variable time period or variable frequency. In variable frequency operation, time period T is varied, keeping either T on or T off that constant. Therefore, there are two methods like constant frequency operation as well as variable frequency operation. In both cases, basically you will have to vary the duty ratio, because the average output voltage is equal to, this is the on period and this is the voltage B for this step down chopper, and when it is off, the voltage equal to 0, and therefore the average voltage can be calculated as, which is equal to T on into the voltage B divided by total time period, or T on B divided by time, or duty ratio D into V. For in that case, basically the duty ratio can be varied either by changing T on, keeping T constant, or by changing the T, keeping T on constant. Therefore, both methods are possible. Therefore, in constant frequency operation, T is kept constant and we are varying the time period so that the average voltage, this is the average voltage dV, this is the average, that the total one is the average voltage, that can be varied by changing the on period, or that automatically that means that off period. For duty ratio can be changed and thereby the output voltage can be changed. Therefore, this is the output voltage across the load V0, and this is the average value of the voltage, which is equal to D into V, and this D equal to T on divided by T. Now coming to the first control strategy, like constant frequency system. Constant frequency system means we are keeping the time period constant. Therefore, T on is varied, keeping the frequency constant. That is, as per this equation, T on divided by T into V, or input voltage, is equal to the average output voltage. Therefore, you will be keeping T constant and T on is varied, keeping the constant, and variation of T on means pulse width is varying. For example, here this is the T period is constant, but this pulse width is varying. Here the pulse width is this much only, maybe say 25% only, duty ratio equal to 25. And now we are, for the same time period, we are increasing the pulse width to say 75. For the duty ratio equal to 75% or 0.75 D, and here 0.25 D. Therefore, here keeping the time period constant means the frequency is kept constant, and by changing the pulse width here, you can vary the duty ratio and thereby you can vary the average output voltage of the chopper. And since the pulse width is changing, this scheme can be also, one other name is that pulse width modulation scheme. This with a constant frequency control technique means that pulse width modulation technique in which the on period is varied. Pulse of the width of the on period is varied. That's called, it's called pulse width modulation scheme. Also called, is also another name is time ratio control. Continuing the constant frequency operation of the chopper, as we have seen previously here, this is the switching pulse in which this is the on period and this is the off period, the total time period t. For this one, duty ratio equal to 25%. On period is equal to 25% or a time period. Duty ratio equal to 25. And the output voltage equal to the input voltage V into 0.25. Therefore, that is D into V. And if you are keeping the time time period constant here, the on periods now increase to 75%, or now duty ratio is equal to T on divided by T is equal to 0.75, or the output voltage is now in 0.75 times V. Now if the input voltage equal to say 100 voltage, corresponding to this one you will be getting 25 volt, and corresponding to this duty ratio you will be getting 75 volts. Therefore, by changing the duty ratio, the output voltage can be changed for a given input voltage, in which here the time period is kept constant, or we can say that frequency, switching frequency is made constant, but the pulse width is being changed. That is why it's called pulse width modulated. And this is also called pulse width modulation technique, which is widely using in power electronic switching circuits. This is a widely using method. And another advantage is that ripple will be less in this one, and the filter size is small, and as well as fast response is these are the advantage of this time ratio control techniques compared to variable frequency control methods. Therefore, this is the method by which you can vary the average output voltage by changing the duty ratio, or by changing the T on, keeping the T constant. Second method is called variable frequency. Second method of control is the variable frequency system chopper that can be controlled by changing the frequency. Changing the frequency means the time period is changed. For example, here see, this is the time period and the on period is this much. Therefore, total duty ratio is equal to T on divided by T is equal to 25%. Now, in order to increase the duty ratio to 75%, or D equal to 0.75, 75%, here what done is that the time period is now reduced. Time period is reduced means frequency is increased now. Here time period is reduced and on period is kept same as this one. Therefore, here the time period is previously this much was the time period. Now it is reduced to this much, or time period is reduced. Therefore, here in this case we can say that one, the on period is 75% of the total time period, or meaning that D equal to 75% or 0.75. Therefore, in this one, we are keeping the on period constant and we are varying the frequency or time period. That is why it's called a frequency modulation method. Frequency is changing. That is, T on is kept constant and T is varied for this one. This same thing can be extended, keeping T of varying. By varying the T of, by keeping the T of constant, we can vary the time period. For example, in this case, T of is this much and on period this much. This is the time period. Here, the duty ratio is equal to T on this much only, 25 divided by T, or duty ratio is equal to 25%. Now, if you keep the off period constant and we are increasing the on period, from here 25 to say 75 here, it is become 75% as such. This is equal to T on divided by T. Now T is increasing now. Previously this was the T. Now T is increased, or frequency is of course the reduced here. And when frequency is reduced, in the case of off period is keeping the off period constant, on period is increased, or the total time period is increasing. Therefore, here the duty ratio is given by T on divided by T equal to 75%. Therefore, in this scheme, on period is kept constant, you are varying the time period, or in this scheme, off period is kept constant, we are varying the time period. In both cases, the frequency is being changed and the duty ratio is being changed. Thereby, the output voltage, average output voltage equal to duty ratio into the input voltage, that can be changed. So this is a variable frequency system that's called frequency modulation method. And one method, as we have seen, on period is kept constant and T is varied. And the second method is that off period is kept constant and T is varied, the second method. For the disadvantage of this variable frequency system is that filter design will be difficult, in variable frequency system, because we have to design a filter for a particular frequency. But since the switching frequency is changing, filter design will be difficult in a variable frequency system. In both cases, basically we are varying the duty ratio D, thereby you can change the average output voltage. Second method of chopper control is called current limit control or CLC. In current limit control technique, duty cycle is controlled by controlling the load current between maximum and minimum. We won't allow the load current to increase above a maximum value. Similarly, not to reduce below a minimum value. Therefore, we are keeping the load current in between this maximum value and minimum value. Therefore, duty cycle is controlled by controlling the load current between maximum and minimum value. The chopper is switched on and off periodically so that the load current is maintained between predetermined maximum and minimum value. Just to explain this one, for example, here we are switching on this step down chopper again. We are switching on this one at this instant, and here when it is switching on, we'll be getting the output voltage equal to say V, and during that period the current through the inductor, because we are getting a positive voltage across the inductor, as the current through the inductor is changing with a positive slope, because we are getting a positive voltage across the inductor. VL equal to L di by dt, di by dt equal to VL by L. Since positive voltage is getting across the inductor, plus here minus here, the di by dt or dIL by dt, rate of change of current through the inductor, is having a positive slope. Therefore, the current is building up from minimum value to the maximum value. Once the current is reaching to the maximum value, you don't want to increase above that one, so that then you will be switching off the chopper switch. Once it is being switched off here, then that inductor energy will be driving a current through that with a polarity plus here and minus here, or the polarity of the voltage across the inductor is changed now, or VL is now negative, or dIL by dt will be negative. Because of that one, the current is having a negative slope, that is dropping from maximum current value Imax to the minimum and value, and once it touches the minimum value, again you want to increase the current, because you want to make the current to within this limit. Therefore, at this stage, again the switch is on, then current is building up, and again switch off, and that is continuing. Therefore, the switching on and off this chopper switch is based on by watching the current waveform. That is by monitoring the current. If once the current is touching the upper limit, you are switching off the chopper. And again, once it is touching the lower limit, again you are switching on the chopper. Therefore, the current will be having a limit within the limit Imax and I minimum. Based on that one, you are controlling the switch. Therefore, that is the principle of chopper current limit control. Therefore, in DC to DC converters, the current value varies between the maximum as well as the minimum level. In this method, the DC-DC converter is turned on and off to confirm that current is preserved between the upper limits and the lower limits. The current through the load, that is R and L, through this load within my max and my minimum. And that is in that case, it is required to monitor the current. You have to monitor the current, load current, and you are bringing the current within this limit I max and I minimum, and based on that we are switching on and switching off. For that method, we call it as current limit control. Basically, when you are changing this on and off period by controlling this current, here on period and on period is changing, automatically off period is also changing, or basically on period divided by total, time period T, that ratio is equal to duty ratio, that will be changing, so that average output voltage will be changing. Therefore, to control this switch, chopper switch, we are watching the current through the load, and we are bringing the current within this maximum and minimum limit. That is what is called the current limit control, CLC. Now, continuing the current limit control CLC of the chopper. In current limit control strategy, the chopper is switched on and off so that the current in the load, or in the, that is this one, the current in the load or in an inductance, this inductor current is maintained between the two limits like I max and I minimum. That is the maximum value and the minimum value, the current is maintained. When the current exceeds the upper limit, that is once the current is exceeding the upper limit, the chopper is switched off. Chopper is switched off, and in that case the current is dropping from, and the chopper is switched off. Then during the off period, the load current freewheels. When switch is off, the current will be freewheeling through this diode, and that will be freewheeling and decreases exponentially. The current is decreasing And when it reaches the lower limit, I minimum this one, again the chopper switch is on, then switcher is that is on, that is repeated. When switch is on, again the current is building up, and once it is reaching the upper limit, that it is switched off and the current will be freewheeling, the current is dropping to the minimum value. Therefore, always the load current is maintained within the maximum and minimum value. Therefore, the ledge chopper is switched on, and this technique can be used only when the load has inductance. If the load only when the load has the inductance, this method of current control limit can be used for the chopper. Therefore, basically by changing this switching of this chopper switch, you are varying the on period, and of course that within the time period of T on by T is changing, or the duty ratio is changing, thereby you are changing the average output voltage is changing. Therefore, we are watching the there should be a mechanism to watch the load current, and by watching the load current, we are controlling the switch, that is whether to be switched on or off. Once the current is touching the maximum limit, we are switching off, and again once it touches the lower limit, again you are switching on. For on and off method is continuing. Basically, that will cause the change in duty ratio, and thereby you will be varying the average output voltage. Therefore, that is the method we call it as current limit control, CLC. This is also widely using method.